Greetings! Today let's solve another equation with radicals, this one. Let's have a closer look at our equation. First of all, we can factor out 2 in the first two terms. We get 2 times x squared minus 3x plus the square root of x squared minus 3x plus 6 plus 2 equals 0. Now we can notice that expression under the root and in braces are very similar, except that 6 is missing in braces. So let's try to add 6 inside the braces. And for that we need to add 12 to the left part, because we have a factor 2 over here. So we add 12 to both parts of the equation. 12 plus 2 times x squared minus 3x plus the square root of x squared minus 3x plus 6 plus 2 equals 12. Now let's rewrite this equation with 6 inside the braces. 2 times x squared minus 3x plus 6 plus the square root of x squared minus 3x plus 6. And let's also move 12 to the left part. So plus 2 minus 12 gives us negative 10 equals 0. Our next step is to somehow get rid of the radicals. And in this example, it is convenient to make a substitution. Y equals the square root of x squared minus 3x plus 6, whence y is non-negative. Using this substitution, we obtain 2y squared plus y minus 10 equals 0. So we have a simple quadratic equation. Discriminant in this case equals 1 minus 4 times 2 times negative 10, and equals 81, which is greater than 0. This means that this quadratic equation has two different real roots. y1 equals negative 1 plus the square root of 81, which is 9, over 2 times 2. And this gives us 8 over 4, which is equal to 2. y2 equals negative 1 minus 9 over 4, and equals negative 5 halves. As we mentioned, y is non-negative, so the second root is a false root. We have only y equals 2. Now we can return to variable x. We know that y equals the square root of x squared minus 3x plus 6, and we also found out that y equals 2. So here we have another equation. Let's raise it to square. We get x squared minus 3x plus 6 equals 4. And now we move 4 to the left and get x squared minus 3x plus 2 equals 0. This is another quadratic equation. Discriminant in this case equals negative 3 squared, which is 9, minus 4 times 1 times 2, and equals 1, which is also greater than 0. So again, we have two different real roots. x1 equals 3 plus 1 over 2 and equals 2, and x2 equals 3 minus 1 over 2 and gives us 1. So we found two roots. Now we need to check if they fit our initial equation. When x equals 2, we get 2 times 2 squared, which is 2 times 4, minus 6 times 2, plus the square root of 2 squared, which is 4, minus 3 times 2, plus 6, plus 2, equals 0. The terms without radicals give us 8 minus 12 plus 2, which is negative 2, plus the square root of 4 minus 6 plus 6. So we have the square root of 4 equals 0. As we can see, this is correct. So x equals 2 is really the root of our equation. Now let's check the second root. X equals 1. In this case, we have 2 times 1 minus 6 times 1 plus the square root of 1 minus 3 plus 6 plus 2 equals 0. The terms without roots give us 2 minus 6 plus 2, which is negative 2, plus the square root of 1 minus 3 plus 6, which is the square root of 4, equals 0. So we obtained the same result. The second root also fits. And now we can write down the answer. And the answer is that the roots of our equation are x equals 1 and 2. That's it, guys. Thanks for watching us. See you.